Okay, students, so a bunch of you wanted me to make a video on the tennis ball problem, so here it is. So the problem was involving 4 tennis balls stacked up. So we have 4 tennis balls stacked up and then put into a cylinder like a tennis ball can. And so let's take a look at the problem. So tennis balls are sold in a cylindrical can with the balls stacked up one on top of each other. A tennis ball has a diameter of 6.7 centimeters. So to the nearest cubic centimeter, what is the minimum volume of the can that holds a stack of 4 tennis balls? About how much empty space will there be in the can? So here's an example of a cylinder. If I had to stack up 4 balls in the cylinder, what would be the minimum volume of the cylinder, and also how much empty space would there be? So let's take a look. Here's our tennis ball can again. So I have the 4 tennis balls in here, and now I just need to figure out the height of the cylinder and the radius, because when I figure out the volume of a cylinder, remember it's the area of the base times the height. And so to figure the area of the circle, I need pi r squared, so I need the radius. So notice I drew in this diameter of this small sphere down here, this tennis ball. So I can draw a diameter any way I want in a tennis ball. I noticed a lot of you were drawing in the diameters horizontally, so whenever you see you think diameter, you think horizontally. But that can be a diameter too. And so that's 6.7 centimeters. Then if I know all of the diameters are 6.7 centimeters, then I can just add up these 4 diameters. So 6.7 times 4 is equal to 26.8 centimeters. So that's the height of the can, of the cylinder. Then the radius is just going to be half the diameter. So that's 3.35. So that's the radius right here. So the radius of the can is going to be 3.35, and then the height is 26.8. Now I just need to figure out the volume of that cylinder. So the volume again is area base, that's what the capital B means, area of the base times the height, and the area of the base is going to be pi r squared. So pi times 3.35 squared equals 11.2225 pi. Now let's take a look at this calculation. So it's 26.8 is my height times the area of my base, which is right here, which gives me 300.763 pi, and that would be centimeters cubed. But wait, this problem's asking us for the volume to the nearest cubic centimeter, so I can't leave it in terms of pi. I need to actually multiply it by pi. So that gives me a volume of 945 centimeters cubed. I think it was like 944.8 or something like that. So I'm going to round that to the nearest cubic centimeter. So that's the nearest integer. Okay, so now let's take a look at the other part of the problem. So we answered what is the minimum volume that the can be, and that has to be the minimum right there. The tennis balls would actually fit quite snugly in there. So it'd actually have to be somewhat bigger than that, right, to fit the tennis balls? But that's the minimum size. So what's the second part of the question is, what is the empty space? Well, that I need to figure out the volume of each of these tennis balls. I need to figure out the volume of one of these tennis balls. So that's the volume of a sphere, which is 4/3 pi r cubed. So that's a more straightforward calculation, right? I can just plug in my radius, which is 3.35, and plug that into my calculator, and I get approximately equal to 157.5 centimeters cubed. That's just for one tennis ball, but I have 4 tennis balls. So I'm going to multiply that number by 4, and the volume of 4 tennis balls is 630 centimeters cubed. But I need to figure out the empty space, so all of these little pockets right in here. So what is all of that empty space going to add up to be? Well, that's just a simple subtraction problem now. I know the total volume is 945. I know the volume of the tennis balls is 630. So the empty space must be 315 centimeters cubed. Wait a minute. Something looks interesting here. Look at these two numbers, 315 and 945. 945 is a multiple of 315. Actually, 315 divided by 945 is 1/3. So the empty space in the cylinder is 1/3 the total volume. Well, that rings a bell, because we know, remember when we looked at hemispheres, a hemisphere, each hemisphere, so each of these half balls, when we looked at that, is 2/3 of the cylinder. So if I like think of each of these as like broken into hemispheres of the cylinder, then each one of these is going to be 2/3. So then that means that the empty space has to be 1/3. So 1/3, 1/3, 1/3. So they're all just 1/3 of the entire cylinder. So that makes a lot of sense. It's interesting how spheres, cones, and cylinders are all kind of related. So anyway, that's all I've got. I hope this helps. Please let me know if you have any questions.